Welcome, everyone. I think we're recording now. Welcome to this workshop, which is about classroom activities using data collected from students. This workshop is part of a series of workshops being conducted with support from a National Science Foundation grant that my colleagues and I have received. Nathan Tinto is the principal investigator on this project. You'll probably be getting emails from me and Nathan and others about this project for years to come. It's a 4-year project to help statistics teachers to teach statistics according to the GAZE recommendations of the American Statistical Association. Today's 1-hour virtual workshop is focused in particular on the idea of classroom activities that make use of data collected from students. Our 3 presenters today will be Laura Callis from Curry College in Massachusetts, followed by Selma Roy from Cal Poly in San Luis Obispo, California, followed by Beth Chance, also at Cal Poly in San Luis Obispo. I forgot to introduce myself. I don't want to start over, but I will introduce myself. My name's Alan Rossman. I teach here at Cal Poly in San Luis Obispo in the statistics department, along with Selma and Beth. I think that's all I wanted to say by way of introduction. Laura is going to go first, followed by Selma, followed by Beth. The plan is for about 15 minutes for each presenter, which will leave us 10 minutes at the end for a Q&A and discussion. And I think, Laura, maybe I can ask you to put a link to the slides in the chat, or Selma or somebody, so that people will have access to the slides. I do ask you, please obviously pay attention to the presenters and don't just read through the slides without listening to the presenters. But it might be helpful for you to have the slides there to also look at the same time. But I've reverted to rambling. I'm going to be quiet now. Thank you all again for being here, and turn it over to Lauren.
Hi, thank you. So I'm going to share my screen so you don't have to have the slides open. But sometimes I know people like to take notes. So thank you so much for being here today. We are going to share some of the different activities that we do in our classes to use data collected from students. So these are some of the reasons. I'm Laura Callis. I teach at Curry College. We're a small school south of Boston, and we have a wide range of students with math backgrounds, and I teach introductory statistics. So almost everybody at the school takes it. And I use class time to gather and use student data because I've found it helps students understand the design of the study, so that when we're unpacking a study and they're making conclusions, if they've gone through a mini version of it themselves, and they're actually making conclusions that have to do with the design of the study. It also helps the students understand the observational units in a particular data set if they've collected the data. And I think it's really engaging for students to engage and talk about topics that they're interested in, and everybody of course is interested in themselves. One thing I've noticed is that it's nice if you can collect the data a little bit ahead of time, because sometimes when I collect the data the day that I use it, sometimes it doesn't really work out. So I might get an observed statistic, for instance, that's exactly the same as a null hypothesis parameter value, and then you're like, okay, guess we're not going to be doing this today. So it's just something to think about as you collect data from students. So I'm just going to talk through 4 examples of things that I do and sort of show you some of the technology that I use to do this. So the first one is when we're talking about the coefficient of determination. There's an echo. Can somebody mute themselves? Okay, thank you. Then I notice that students get that confused with correlation coefficient a lot. So we do an investigation using the price of Legos, and students have lots of ideas about what impacts the price of Legos. And then we just Google the price of different Lego sets, and we use a Google form. And so if you're on slide 3 and you want to see an example of a Google form, you can click on that link. And you can see that, they put in the set number so we can check for duplicates, and they put in the selling price, the number of pieces. They put what type of set it is, a Marvel set or a classic set. And then that turns into a Google Sheet. And sometimes we do a little recoding, like, I have a 7-year-old, so I know that Ninjago and Create and Friends, those are all Lego owned brands. So we recode those as Lego, and then Mario or Star Wars or Marvel superheroes, those are licensed brands. And so we might be wondering if there's a different relationship there. And then we copy and paste that data and we put it into an applet. And so I'm gonna put the links in the chat for you, but they're also on the slides in case you wanted to play as we go. So this is the data for Legos that my students collected a couple semesters ago. And then this is going to be, oh, I'll just click here. This is the applet that I'm going to use in case you want to play along. So in this applet, I'm going to, and you can also find it again by going, just Googling Rossman chance and then clicking on multiple variables. They come up. So I clear the data and then I take the data that I want from the spreadsheet that came from the Google form. So the type of Lego set and the number of pieces and the price. And I check that I don't have any missing values. And then I copy it and then I paste it in and then I click use data. That's important. And then you can see that the variables have changed. And I'm interested in predicting the price from the number of pieces in the set. And it makes sense that, you know, if you have a bigger set, more pieces, then it's going to be a more expensive set. And if students have collected the data themselves instead of just using a spreadsheet, then I make them find the dot that represents their Lego set. And then that way they're able to sort of orient themselves to the data a little bit better if they're the ones that collected it. And then they can click show equation to get a prediction line. And then I think this all, when they've collected the data themselves, they can also more easily understand what a residual is. So they can use the prediction to figure out what the price would be if we knew the number of pieces, the predicted price, and find that difference between the actual price. And so they sort of understand and can visualize that when they themselves have chosen one value. And then down here, we can see that we can actually predict a lot of the variation in price, knowing the number of pieces. We can get R squared over here. There's lots of different things you can click. And I want them to understand R squared, so I'll also have them subset by the type of set it is. Is it a licensed set or is it, you know, just a Lego set, like a bucket of bricks, or is it, you know, some superheroes? And they could see that there's two different lines. And they can see the two different prediction equations and sort of visualize that that red line is getting closer to those red points overall. The blue line representing the Lego owned brands is getting closer to the blue points overall. And they can see that that R squared is going up a little bit too. We're better able to predict the price based off of the number of pieces if we also know if it's a special set. So some of the other activities that we do a time estimation activity, and this is when we're introducing a hypothesis testing for the mean. So I've noticed that students, like when we do a hypothesis test, they start to conclude things that sound like they're thinking about individual people. So they'll say, well, most people do this or most people do that. And they didn't seem to realize when I first started teaching it that we're talking about the mean. That's what we're testing. So what we do is I have them watch a video. And I don't tell them that we're doing time estimating, but it's a video about my son and he's playing in a hammock and it's short. And I tell them there's going to be a quiz on how cute my son is. And then I have them fill out a Google form where they estimate how long the video is. And then we use the Google Sheet to create a graph. I make them find themselves on the graph so they can kind of get a sense of that, of what the data means. And then we think about, well, we know from other studies of people estimating things that individual people might be wrong. But there was a book that came out a few years ago, The Wisdom of Crowds, that said that, well, if you get enough people and they all make an estimate and then you average that estimate, the average is often correct. So even though individual people are wrong, the average might be correct. So we wonder, you know, our estimate as a class may have been above, the average may have been above the real length of the video. But if we talk to everybody in the whole world and got them to estimate the length of this video, could it be that actually the average for everybody in the whole world would be the same as the actual length of that video? And is the difference between our class's average and the actual length of the video, is that just due to sampling variation? Because samples are always different. And so I found that when we do this activity, it feels like they understand that we're talking about the mean and we're not saying, oh, most people don't estimate well or something like that. We're talking about the group mean. So some of the other activities I do, students like often on my check-ins, they tell me that they're really stressed or they're really tired. So I started doing a Google form that just asks them, you know, how much did you sleep last night? How stressed are you on a scale of 1 to 10? Do you drink coffee? Do you exercise? Things like that. And then I pulled the data into CodeApp, and there's a link here. I'll also put the link in the chat so that you can play. So this is CodeApp student data. Whoops, there we go. So if you click on data, if you're on slide 4, it has it preloaded. If you want help learning how to use CodeApp, you can just send me an email and I can, you know, meet up with you on Zoom or something and show you how. But the nice thing about CodeApp is that you don't have to know what type of graph you want, and you don't have to know the name of the graph, and you don't have to know where to click. You just click graph and say we're interested in stress. So I just drag stress over and let go, and it's created a graph for me of how stressed students feel. I ask students to find a dot that might represent them so they can understand what the data is. Maybe we're interested in our athletes. Are athletes generally stressed at a different rate than non-athletes? And so we have all the athletes up here and the non-athletes down there. And it's kind of hard to tell visually. So maybe I want to use a different type of graph, like a box plot. Maybe we want to write some sentences about making sense of what these different parts of the box plot are. If I want to calculate the mean, I just click on mean. And if I hover over it, it will tell me the mean, or I can just click show measure label. And I know we have at least one person today who said that they're looking for things to do with future elementary teachers. And this is nice because you can just drag and drop, right? You don't have to worry about click on this and write in this code. It's pretty fast. And so what students will do is they'll choose their own research question, they'll create their own graph, and then they have to write statements that connect to the graph that show, you know, how are you using this graph to support your conclusion, and then they meet with each other and present to each other. And then the last one I want to talk about that, let me see how much time I have. We have a few minutes, is an example of where students are kind of walking through the study itself so they can understand the design of the study, because when they don't sort of feel the study themselves, then they kind of have a hard time understanding what everything's about. So this is a real study on ESP. One person is a sender, so they look at a picture and they try to beam that picture mentally to a receiver. And the receiver in another room is a person who is looking at 4 pictures and trying to guess which picture the sender is looking at. And so if we were going to model the null hypothesis, this idea that there's no such thing as ESP and the person who's receiving the picture is just kind of guessing, then we could have a spinner with 4 sections. One of those sections represents the correct picture that the sender is trying to mentally send them a picture of. And we could see how often would you randomly guess the correct picture. So this is when we're developing a chance model and understanding the sort of logic of hypothesis testing. So when I teach this lesson, I use Desmos, and I have a link here so we can kind of play with it and you can see what Desmos looks like as a student and as a teacher. I'll just put the link in there. You can click on the link in the chat. You can click on the link on slide 5, or you can go to student.desmos.com and then it'll ask you for a code, and the code is S935ZP. And I'll click 2 so you can see what it looks like. And if students sign in, it saves their work, but they don't have to sign in if they don't want to. So I always have a check-in slide to see how students are doing today, and they can write me a little something here. And then over on the teacher side, on the summary tab, I can see all the people that have accessed it. And these dots mean that they've written something, and the gray means they haven't written something yet. So I can check that everybody's able to access it. And I can also see what people are saying. So let me go back over here. So I can see how people are feeling today and get a big picture. This is really great for like large classes because you can get a lot of information about what students are thinking generally and sort of react in the moment. It's also good for classes where you have some quiet students in the back who are afraid to speak up. This way I'm able to give feedback on everybody's thinking. And I use this in my online classes so that I can see what they're thinking in real time. I use it a lot in high flex classes where some people are on Zoom, some people are in front of me. This way I could see what everybody's thinking. So I want to give you a minute to just sort of play with the first couple of slides. So what do you know, maybe just a sentence or half a sentence on slide 2. If the participants were not psychic, how often do you think they'd be right? Slide 3 is matching. The way you do it is if you grab a card and hover and you see how it lights up, then I'm able to see how you've matched things on my end. And then over on slide 4, just go ahead and click what you think is right, and then I'll show you what it looks like on the teacher end. So I'll give folks a few minutes. I can see how many people and who is on each slide. So often I'll be like, hey, Jamie, join us on slide 4. I'll give folks a second. Okay. So if I go under summary, again, I can see how many people have answered slide 4, and that way I can say like, okay, I need to wait a few more minutes. It helps me with my pacing so I don't go too fast. And then if I click on teacher, if I click this show correctness box, I can see how many people are answering correct, what their explanations are, who do I need to go over and chat with to say, oh, actually, it's more like this. If I want to just give direct feedback, I can say, I can click on that and they'll get a little message up here that says, you know, good start, but we use pi for parameters or something like that. And so I can give everybody feedback in real time. And so I only have a couple of minutes, so we're not going to be able to do breakout groups. But what I would do in something like this is I would put students into breakout groups in Zoom or, you know, just in front of me. And I would have one person be the sender and one person be the receiver. And the sender is trying to concentrate on one picture and the receiver is guessing which picture it is. And they do that 6 times. They count up how many times they were right and put it in the graph, and we get a graph for the whole class. And then we sort of walk through, how would you simulate this? How do you use the applet? What are you getting? And then that way I can make sure that I give everybody feedback. So I'm going to pass it over to Soma, but if you want to chat more, this is my email address, and at the end we'll tell you how you can join Slack and be a part of our community and share our ideas. So I'll stop sharing.
Thanks, Laura. One question real quickly. Laura, I saw a question in the chat about how many students do you typically have in a class?
I have 25 right now.
Thank you.
Yeah.
Go ahead, Soma.
Thank you. So I'm going to share only a couple of examples. They're mostly univariate. Hopefully you can find something here that's going to be helpful for you for your classes. So when I start doing one proportion tests or one proportion inference, which is pretty much in the beginning of the quarter or the term here, this is an example that I use where we talk about this example or this story. A legendary story on college campuses concerns 2 students who missed class, actually a chemistry exam, because of excessive partying, but they claim that it was because their car had a flat tire. So the professor allows them to take the makeup exam. He sends them to separate rooms. The first question worth 5 points, quite easy. The second question worth 95 points asks, which tire was it? So you know, you can chat if you like. Which tire would you pick if you were one of these students? And so how do I collect the data for this? So most of the time, I just ask them show of hands. Sometimes I put this in like a quiz before they're going to come to class, so like a pre-lab or a pre-class quiz maybe. So far, I've had success almost always with this example in getting them to be in the direction that I want them to be in. But yeah, like Laura mentioned in her, when she was talking about her examples, sometimes it might be a good idea to kind of collect the data before you come to class, so you know you can prepare better. So typically I'll kind of do a show of hands, but before I collect the data, I kind of write on a little slip of paper, I'll write right front, fold it and hand it over to a student who is in class and say, don't open it till after we've collected the data. Or I'll have a slide already prepared that says right front, because I am hypothesizing before I'm going to look at the data that more often than not, students are going to pick the right front tire more often than they would pick like if they were going to be picking by chance alone. So I want to form a conjecture before I look at the data, not let the data decide what my conjecture should be. So what typically happens, typically students do tend to pick the right front tire. And so I'll show you kind of some of my ideas on why I collect the data and what to do with the data, with this particular data. So I can do a one proportion inference for sure. And the one proportion inference question turns out to be, do students tend to choose the right front tire more often than they would by chance alone? So, we're thinking, okay, well, does this choice happen more than 25% of the time? And because there are 4 tires on a car, are they picking that one tire more often than a quarter of the time? We can do a tactile simulation. I will kind of ask that, we probably need to think carefully about, do you really want to do a tactile simulation in this context? Because it matters how big your class size is. So like, if you have 50 students, you're probably not going to be wanting them to be spending time doing a simulation with a class size of 50 using a deck of cards. But maybe if you only have 12 or 15 students, it's not so bad. So you could do a deck of cards, you could do a spinner, anything of that kind. Or you could go straight to the Rossmann-Chance applets, use the one proportion applet there. The last time I did this data, I had 55 students. So of course, we didn't do a tactile simulation. We went on to the one proportion applet, and I want to kind of quickly show you if this works out. This is kind of what the Rossmann-Chance one proportion applet. Many of you have probably seen this already. So this is typically an example that I use maybe the second time around in class. So like they've already seen one context maybe where it's a 50-50 choice, and now they're looking at 1 out of 4. So the question becomes, would you leave probability of heads at 0.5, or do you want to change it to something else? And it's nice to have the students tell me that this should be 0.25 because it's 1 out of 4 instead of 0.5 sample size in this particular case. So again, this is a part where I let students, especially if they are not working on the computer or the applet themselves, I let them be my navigator or driver, so tell me where to go. So they'll tell me this is 55. We can do just one time to see what it looks like. So if you do it one time, it kind of uses a spinner instead of a coin. And then it says, well, if it were by chance, it would, one of the values that could happen is 16 out of 55 picking the right front tire. And so you can do this several more times. I'm going to go crank this up to a big enough number to give me 1,000 reps. And that shows me, okay, here's what some typical values would be. So, 12 out of 55, pretty typical. 13 out of 55, pretty typical. So you can kind of see what the typical, what could have happened more typically if these 55 students were picking a tire by random chance alone. How often would they have picked that right front tire? Well, in our case, we had 22. So 22 was kind of out there. So if I go back to my, where is it now? All right, I think it stopped sharing. So here am I. So, go back one time. So in my case, there were 22 students who had picked the right front tire. So 22 out of 55 was looking pretty out there in the tail, giving me a p-value of about 0.01. So that's one use of that data set. It's easy to collect. It's a fun situation where they kind of, compare with each other later on. And then I tell them, if you were the students in the class, what do you think it would have played out at if you were one of the 2 students? Because it does look like students kind of tend to agree on which tire they're going to pick. So maybe you would have been fine if you were one of the 2 students. And maybe you would have picked, both of you would have picked the right front tire. Another use of that data set is to do a goodness of fit. So if students tend to pick the 4 different tires not equally often, or is it plausible that, or how does it fit equal choice, equal chance choices distribution? So again, you can do a tactile simulation, but I'd be careful if it's a large sample size. So like I said, in my classes was 55 students. I'm probably not going to do that. The nice thing about this is now that they are in this 4 choices situation, you can actually create an opportunity for students can build their own statistics. So how are they going to compare the observed distribution, which turned out to be something like this, to what the expected distribution would have been had the choices been equally popular, all 4 choices had been equally popular. So this is what the right front, left rear, right rear counts look like, and then comparing it to some expected counts. So you don't necessarily have to go to the chi-square distribution if you're thinking of the chi-square distribution. And if you think that your students are not ready for it, you don't have to go there. You can kind of talk about, okay, how would you measure how much the discrepancy is between what you're seeing in our data, what you're expecting to see in our data. And the Rossmann chance applets also have that. So let's see if I can. So this is the data here. If you go down here, there's your goodness of fit statistic and or goodness of fit applet, and you can put in the data here. So I'm just going to go ahead and put, I had left front was 20, right front was 22, left rear was 5, and right rear was 8. If I say use table, it kind of gives me that the observed counts, the distribution of the observed counts. I can do the same kinds of things with the shuffling. But here, what we're looking at is some choices. So I want to talk to you a little bit about this before I go on to something else. So here's the observed counts. Here are the observed percentages for the various choices. You can choose your statistic. You can choose your statistic to be the max minus min. So what was the most popular choice versus the most or the least popular choice? So that's the difference between the proportions of the most popular and the least popular. You also have something called the MAD statistic. So that looks at the absolute difference or the mean absolute difference. And then you have the chi-square, the minimum tally, maximum tally, and so on. So let's stay with the max minus min and see what happens. So we can do a show sampling distribution. So it already automatically picks these equal probabilities for our hypothesized probabilities, but you can change them. So if you think that this distribution should match something else, you can change these numbers. Of course, they should all add to 1. You can look at a plot of the data and generate that. So if you say sample, it's going to pretend as if it's all 4 choices are equally likely, and it's going to create this possible distribution of what these choices distribution could have looked like had students been choosing randomly between the 4 or among the 4 options. And you can do this a few different times and see how the max minus min statistic changes from shuffle to shuffle. I can crank this up again to get a better understanding of the long run pattern of what this max minus min statistic could have looked like had it been by chance. And then I can say, okay, well, how does the statistic I looked at, so that's in my observed data, compared to this distribution of what could have happened by chance, what this pattern of distribution pattern looks like if students were just picking all these 4 different choices by chance alone, or just randomly picking between these 4 choices. And so you can put that 0.309 here. How far away or how extreme is this difference? And we see that it's actually pretty unusual again. All right. Okay. So again, we see like there's pretty strong evidence that not all tires are picked equally often. And this you could have already predicted. If you've already seen the 1 proportion, you know that they're not getting picked equally often. Another example that I use, again, this is a univariate case, very simple example, just to kind of get students thinking about what a quantitative variable might look like. Something that is easily collectible is how many steps did you take yesterday? And many students have smartphones now, which have apps that already count their steps. Sometimes they have watches that count their steps. And I give them the option of leaving it blank. I'd rather they didn't put anything in if they didn't know the answer than put something that they made up. So they report that, and sometimes I include that in an optional, as an optional question on a survey or a pre-class lab or something like that. This is kind of what the data ended up looking like from the most recent time. I had 49 students complete the survey and submit an answer for the steps. And this is a nice example of where they can actually see themselves in the data. So they are looking at each of these little blocks is a student, and you can see like the student was taking like 22,000 plus steps, and why or how is that happening? And then talking about all this variability. So what do you see? What do you notice in the distribution? You can talk about the histogram, you can talk about the box plot, and so on. So this particular graph was generated in our descriptive statistics applet. So, and it also lets you create these obtain these numerical statistics. And if we have time at the end, I can show you what the data look like and how to put that put that in the descriptive statistics applet. But what are some of the things that we talk about in this particular context? It gives the students an opportunity to actually see themselves and connect with that dot. So where in the categorical data case, you can't really say, okay, that dot belongs to me because it's all on these bars. You can say I'm in that bar versus I'm in that other bar. But here, at least, you can kind of, each student has a dot. They can make those connections as to, oh, look, and especially if students are willing to identify themselves, they can say, hey, how come you were taking more than 22,000 steps that day? So we can use that data to kind of estimate what the average number of steps is that students take. We can compare them to CDC's recommended 10,000 steps. But more recently, if you're not taking 10,000 steps daily, you'll be happy to know that there was a recent article in the Journal of the American Medical Association that says that 7,000 steps is actually good enough. So we can compare students to the 7,000. So if I actually go back and look at this data set, our students are probably not doing that great compared to the 10,000. Maybe they're okay with the 7,000 recommendation. What else? We can talk about who these data are representative of, because not everybody has a step counter, or maybe they didn't have their step counter with them that day. So what happens? Whom are we actually talking about in the data set? Whom are we leaving out? Who is not in the data set? Who are we not representing? We can discuss the credibility of self-reported data. Like a couple of students reported values like 5,000 and 1,500. Are these rounded values? Did you actually exactly take 5,000 steps, or did you just round this up? Are you estimating it? Did you have a counter, or you thought, it sounds good to say 5,000, so I'll say 5,000. So like talking about those kinds of things, of course, without calling on people, or I don't, I actually anonymize the data before I share it with the students, just so they feel like, they don't have to be, they can look at themselves in the data, but they don't have to let other people know that they are that data point. And also it kind of motivates the idea of variability, right? That we are different, that we are, maybe the person who was taking 22,000 steps is a triathlon, is training for the triathlon. So if they are practicing for it, maybe that's why they have that kind of data. So what might explain the variability in our data? All right. The last example that I have for you is more of a long-term data collection that our students, and I use all of these in our introductory statistics classes. And this one is, this particular one is called the Time Management Project. And it is part of this quarter-long project. It's a team project, and the focus is on data visualization and descriptive statistics. So they don't do anything beyond that. They just create graphs and create numerical statistics and kind of do some very basic comparison contrast statements. The thing that I like about this particular example is that it's fairly easy to collect the data. It gives students an opportunity to reflect on how their use of time is changing potentially from the beginning of the term to the end of the term. So on 3 particular aspects of their daily lives, how much sleep are they getting? How much time are they spending studying outside of classes? And then a third variable that might be something that they decide on themselves. Each student is supposed to maintain their own spreadsheet. The team collectively decides on what this third variable is going to be. And most of the time, it turns out to be how much time they're spending working out or how much time they're spending on the screen and so on. And then at the end of the term, they kind of combine their data sets and then generate some graphs as well, create some graphs, create some numerical statistics, generate a report of their analysis. And for their analysis, they use R. So I break this project up into various pieces. There are smaller pieces that are due at the beginning of the term or towards the middle of the term, and then the bigger report is due at the end. I put the smaller pieces in at the beginning, so to kind of make sure that they are staying accountable for different things, and the smaller pieces are worth points, but they're lower stakes. So for example, the first month they'll collect the data, but the end of data collection, they do have to turn in that data spreadsheet. It's worth only 5 points out of a 70-point project, but it's still it's enough that they do it on time. After they collect the data and turn that sheet in, we spend some class time on making sure that they're okay with carrying out the analysis in R. Then they kind of work outside of class to generate that report or the memo. They turn in a draft of the memo. We spend some time in class doing a peer review, making sure that the product is kind of, that they have the correct graphs, that they have the correct numerical statistics. So that's what the peer review process does, is make sure that when they come to me, they're actually pretty good and, in very good shape, basically. And then they turn in their report and the R code. So here's some sample of what their data of their sample work of their student work actually. So here's an example of a graph they might create. This graph is for one student, and they're looking at how from day 0 to day 35 their sleep time and study time changed over these 35 days. And you can see that
I should ask you to wrap it up in a minute here, Selma.
Yes, and then they can see that the fluctuations, then they get to kind of reflect on what days, why certain days had lower times and certain days had higher times and so on. Here's kind of their third variable. For the third variable, they compare across the 3 people on their team. And you can see that this particular group decided on screen time as their third variable. And it's actually kind of interesting to see how much time they might be spending on a screen. So for example, there's some that one of the students spent over 700 minutes on the screen time on a particular day. So it's kind of interesting when it comes to me when I see these graphs. Some people keep it simple and kind of just create simple plots with the day on the x-axis and use a plot function and base R. Some people go fancy and do the ggplot. I do not teach ggplot in the class, but they decide to pursue it on their own. So that's kind of nice, or motivates them to learn. I liked these particular graphs because they actually use the time series functions in these. But more interestingly, how the distributions of the, how the time on study and coursework or sleep are changing, that sometimes the time spent on coursework is going higher for the time spent sleeping. And so then I kind of bring it up with them and talk to them about it. Like, if this is happening, maybe you need to reflect on why you're not getting enough sleep, or why these patterns are happening. So, and that's kind of it. I'll go ahead and hand it over to Beth.
And then that moves everything. Did you want to answer? There was one question in the chat about R, if you wanted to say more on that.
Do you have all of your intro stat students learn R coding as well as the intro stat topics?
So in this particular class, we do have some R. but this is more like an orientation to the discipline of statistics. So we don't do as much on like, inference and stuff like that. We do more like, here are the skills that you'll need for the next 4 years. We do some computing, we do some like data ethics, study design ideas, and then resources on campus kind of thing.
Those are all statistics majors.
Yes, they're all statistics majors, that's correct.
Thank you. Go ahead, Beth, please.
And we will try and make sure that we've shared all these links. They should be active in the slide deck, and we'll share the slide deck, but we can also pull out the links as well. Because I took a challenge of, do I actually do this in my courses, what we're encouraging you to do? And so I just looked at the last time I taught our intro course for non-majors, mostly psychology, social science majors, and was happy to see that almost once a week I would do something that I would say is focused on data collected by the students or about the students. And so the very first one is matching variables to graphs, and I'll talk about that in a minute. Now with the forehead thermometers, one day I'll just go ahead and shoot everybody's forehead and I collect all their temperature data. Maybe I just have them write it down and then they submit it through a Google form later. And what's especially nice about those Google forms is then everybody can instantly have access to the data. Although I agree with Laura's recommendation and to collect it ahead of time so you have a chance to look at it and possibly do a little bit of cleaning. Sometimes I cheat and combine 2 sections together. Sometimes I remove some outliers, things like that, if it's not working quite so well. Or maybe I just pick one section that worked better than the other section. And my section sizes are about 35, 36. And then by week 2, we're doing this Bob versus Tim, where they get presented 2 pictures of people and they're asked which one is named Bob and which one's named Tim. And so that's usually the last question for a free point on my first quiz. And then again, I collect that data and we come back later in the class and analyze it. That turns into a test of significance for one proportion. And what I put over here is, do these activities actually work? And so Bob and Tim, I'm surprised, has always worked, even when I've changed ages of students and different types of students. They seem to be very consistent in which face they think looks like a Bob and which one they think looks like a Tim. And then there's a research study behind it. And so this is just following up on that research study with the data collected on the students in my class, but then also with the question, well, sure, it worked for you, but do you think this is true in general? What population are you willing to generalize to? Things like that. And then the next week, there may be taking samples of words from the Gettysburg Address. And this usually works very well that the class, so everybody comes up and puts the average of their 10 words as a dot plot on the board. And then I reveal the real mean length of the words, and they see that almost everybody is higher than that. And so we tend to oversample the longer words. And so it's a real nice visual that they create. They're one of those dots to illustrate sampling bias. Later, as they come into class one day, I'll just ask them how many hours of sleep they got the night before. I'll type them into a spreadsheet as they come in. So it's quick, it doesn't take any additional class time. It's already in the spreadsheet. And then I save that and we come back later and analyze it. And that one's nice because there usually are outliers, as Soma was talking about, and things that you can follow up with about students. And the video comparison I'll talk about in a minute. And then chip melting, I do bring semi-sweet and butterscotch chips into class and they melt them. And then we talk about variation in melting times. And then we set up a paired design. And that one doesn't always work well with the data. Most of these have turned in, I usually do one focus lab for the week where we collect the data and we analyze the data and we write up a report. And so those are the ones that I've been turning more into data collected from students. But this one, it doesn't always show what I want as far as a reduction in variability. So it maybe is more of a follow-up homework question rather than the main lab. For the matching variables to graphs, this idea has been around for a while, that if you want students to really understand the graphs, give them some graphs without the labels, without the numbers, see if they can talk about shape, distribution, things like that. But I just replaced it with the data collected on them. So part of my first day of class survey that they fill out in Canvas asks some questions like this. And again, participation is voluntary, but they do get credit for doing it. And then one of their first homework assignments or lab assignment is to work with a partner. Here are the graphs for some of these variables, which variable goes with which graph. And these are the instructions I give them. And this should be an active link if you want to see the assignment. But these are the instructions I give them. And I warn them, I don't really care which variable goes with which graph. I want to hear about your justifications. How are you interacting with the graph? What clues did you find in the graph? Different people may match up different ways, and that's totally fine, as long as you have the ability to kind of explain your reasoning. And this is, again, it doesn't always turn out the same way, but usually there's one graph that has a big spike here and then a gap before you see more data. Other ones maybe don't have the 0 values or that gap. This ends up being maybe haircut prices, where a lot of people will say they got it cut for free. So we put that in for 0 before you see kind of minimum prices. And then they talk about skewness. You know, there's going to be women, if depending how you define a haircut, maybe you're spending a lot more. So they're making a lot of assumptions, but I really encourage them to tell me what those assumptions are and how they relate to the graph. But again, they're really just thinking about what these graphs mean. What does it mean to have a lot of observations here and a gap of observations, and to have these different scalings, or to have this space between these numbers? And the main reason I like this activity is it really helps them get the feel for what the course is going to be like, that it is going to be a lot more about explanations. They're not always going to be one right answer like in a math class, and that I really want them to be able to explain and justify and, you know, feel comfortable with having different answers. The memory test wasn't on that first list, but it's one of my favorite now, partly because I have a new form, and teachers can go into this form and you can put in an identifier and it'll send you a URL, and you can kind of get a unique URL. I'll see if I can demo this real quick. So you can generate a URL, and then it tells you what URL to give your students. And then they can do this test online. And again, it's going to collect the data. And so they start the test, and there's going to be a sequence of letters. They're told they have 20 seconds to memorize that sequence of letters in order. And then they're going to write down the sequence of letters. And we've built in some things, so hopefully they can't just copy this and save it after using it with students, because this sequence is going to go away in a second. And then they put in their list, and I'm not good this, I think this is the different data set. And then it'll determine the score for them. They got 3 correct. It'll ask them a couple other variables, and then it'll give them access. They submit the results. They're all going to go into a Google spreadsheet with that, so you can sort and just find those. Or once they submit, then you can go to some, I have to answer all the questions. You can go to different links, and it'll load the data into the applet, so they don't even have to do the copy and paste part. But this isn't the important part. The important part is getting the data from them and having them be that participant in the experiment. And they don't even know it's an experiment at first. So usually what I would do this is everybody gets a slip of paper. They're told there's going to be these letters on the back. They turn it over, they memorize, and then maybe turn to a neighbor for scoring. So again, that idea of trying to have that blindness and the real scoring rather than being able to make up their own scores type thing. And then they would turn in that slip, and it wouldn't take me that long to type it in and maybe type in some of these other variables. But what they don't know is that there were these 2 sequences. And so one we call meaningful chunks. And so again, we tie this back to the genuine research. A lot of students have heard about this in their psychology course. So this gives them a direct application of it, or participation of it. And then it's pretty easy for them to conjecture which sequence they think will be easier to memorize. And maybe by how much. When they hear about chunking, phone numbers used to be 7 digits. So maybe I can remember 7 chunks versus 7 letters. That usually doesn't show up in the data. You usually do see an improvement and a shift. And what I really love about this is you usually see this clustering or this clumping. And so I make students be data detective, what's causing that. And eventually they figure out that most of these are multiples of 3. So people were remembering these chunks in groups of 3 before they were making a mistake. And something else I meant to say earlier with the matching variables to graphs, a lot of students will say things like, oh, well, this one has more variability. Like, well, how can you change that? What does it mean to have more variability when you don't have numbers and you have totally different scales? So we start those conversations about variability early, and then they can talk about that here. But not only do I have that shift in mean, but maybe I have more variability in the results as well, and why that might be. So we do come back and analyze their data. Again, I try and use their data. If their data really, really didn't work, maybe I'll bring in some data for a previous term. Or if I have a really small class, I'll combine that with the sections or a previous term, things like that. And then they can get into lots of questions like, was this a well-designed study? How would you do it better? Again, who can you generalize these results to? And that's something where I like to collect the data on the students a lot, but then keep reminding them, then what's the cost of that is the generalizability. And then here they can talk about causation, or if you have those other variables, then they can use like the multiple variables applet that Laura was showing you to kind of see, are there differences in those variables as well, and how well people are doing, and explaining differences between the groups. And then the third one is about comparing videos. And so the study I usually do for comparing two proportions is this dolphin therapy study. And they see that people who swam with dolphins tend to have success, meaning a reduction in depression symptoms, more often than people who just got to swim. And so then we're going to ask whether this is a statistically significant difference. And for a lot of these lab assignments, I make students do a pre-lab first, where we're maybe just defining variables, maybe looking at some of the initial graphs, things I want them to do outside of class. So what I learned in Canvas during COVID is I can set up 3 different questions in the same block, and it's going to randomly pick one of those questions. So some students will get this question, some students will get this question. So what I've been doing a little bit lately is randomizing some kind of explanation of an idea to see if one of those seems to help students understand the idea a little bit more. So here they're going to do card shuffling. And so do we use spinners? Do we do the tactile simulation? Do we do a demo of the applet? Do we ask them to go in and use the applet? These are some of the things that we've been playing with. And these links hopefully will be accessible to you as well. But this particular last term, there was just the 3 different links, some different videos or a different reading assignment to see if that made a difference. And this is a pre-lab assignment. They get their answers and then they start the lab. The pre-lab assignments are low stakes. Plus, after I revealed to them that there's multiple versions, they all get full credit on that assignment. But I try and make it a little bit more authentic if I can. And so they all respond to the same multiple choice questions. And then we come back and do the actual research study about the dolphins. But the best part is later in the course, when we want to compare 2 means, I say, you know what, you had these different treatments and you had these different scores. Let's see if there's a significant difference across the treatments. So this is going to be our ANOVA where we're comparing 3 means. But then in the lab assignment, again, I make them play the role of investigator. Which treatment did you have? What about the fidelity of the treatment, and get them to reflect on that? Look at all of them now. Which one do you think is going to be more effective? Again, they're discussing this in a group. And then we analyze the data. And then at the end of the lab, I ask them questions like, well, what did you learn? Was it what we expected to see? And then what improvements do you suggest? And what I found, these are just some of the student examples of why they thought one might be better than the other, which one they thought might help them learn more. And then we'll talk about things like having the visual or having the demonstration with the visual, or just being able to do it myself rather than just being told. There's just rich information here that helps me as a teacher, and maybe they learn something as well. And it just really gave us a lot to talk about. And I just saw their engagement really go up when it was, again, data about them and they were interested in the answer. These are some other activities I've done in the past. Partly they're over here because the success rate is a little bit lower. There's evidence that novices are less likely to throw rock in rock, paper, scissors. Doesn't usually work out in my class. Some of these, like Coke versus Pepsi, work very well. They're just a lot more setup time. So we're hoping one thing we showed you today is things that take a little bit less setup time, but these are things that I'm happy to talk about later as well. So just to summarize, sorry, Alan. So I think these have mostly been said, but also not only students seeing themselves in the data, maybe they're learning something about themselves as well. How much sleep am I supposed to get, and am I getting enough? I think instead of just showing them that bias can happen when they've been biased, I think it makes it more believable. When they're one of those dots on the board, that gives you something to always come back to link to. And especially in my curriculum, where I do a lot with simulation-based inference, and we say, here's the real data, here's the made-up data, how do you compare them? Well, if the real data really is real data, and they know it because it was their data, I think it makes that distinction more clear. And I just think students want to know the answer to the research questions more than some of the messy ones. And I think it's actually a benefit that the results vary every time. Every quarter, I get different results. So I know they're not just copying in some lab report from the previous results. And the data is messy, and it gives us lots of opportunities to talk about that instead of students thinking they always get this nice, very clean data. But it does take a little bit more prior planning and energy, as we've talked about. Do you have backup plans, even if it's just another data set? Be ready to combine sample size across sections. Do ensure anonymity, as we talked about. I used to do a lot more with food, but then food allergies, or just I don't want students thinking statistics is all about playing with food. But boy, they really did love that Reese's Pieces one. So trade-offs there. So maybe just not all about food. And then I used to think if I did a lot more of these, maybe I wouldn't do a student collection project that lasted the whole term, but I still find that student collection project has a lot of benefit, even if we've been collecting data throughout the course as well. So we have a few minutes. I'll turn it back to Alan. I threw some email addresses on here. I threw a Slack link on here, but I don't know if that's what you wanted to do.
Sounds good. Thank you very much. So thank you again for coming, everyone. We do have a few minutes for Q&A. I put a link in the chat to a very brief evaluation form for this workshop. I mentioned at the outset, this is supported by a grant from NSF. So we'd like to collect some data on whether you thought this was worthwhile, whether you think this will affect and have an impact on your own teaching. So please do take less than 5 minutes, probably more like 2 or 3 minutes to fill out the evaluation form. You'll notice Beth has a link at the bottom of the slide you see now to join a Slack channel. I don't know if that's the right word or not, but a Slack thingy where people who have been to our workshops can get together and share ideas and ask questions and things like that. I'll also send out the recording of this presentation later, either later today or over the weekend or Monday morning at the latest. But let me be quiet and see if anyone wants to ask a question, either in the chat or feel free to unmute and ask away.
I will say that Slack invite expires in 30 days. So if you decide later, just send us an email.
Beth, there was a question about how you handle when you delete outliers. Like, do you tell students that you did it or anything like that?
Yeah, and something I meant to emphasize was that idea of student choice. So both Soma and I talked about maybe give them several variables and they can decide which ones they want to use. I sometimes do that with outliers as well and leave it up to the group, and different groups may make different decisions, but always get them in that habit of documenting when they do that. Unless I think it's going to be something that is going to out a student or be too embarrassing, but I haven't had that too often with the variables we've been talking about today.
Another question, comments? I reposted the evaluation form link just now.
And I posted the Google site for our project because I think the resources from other workshops are also on there.
Oh, is there 2 ways? Oh, there is 2 ways, yes.
Well, it is the top of the hour, so let me wrap things up. Thanks again to everyone for coming. Thanks very much to the presenters. I will send out the link to the recording at some point in the next 72 hours here. But thank you very much.
Actually,
There's one more question in the chat.
I think that